Hello everyone. So today we will be solving Koko Eating Banana problem on roll code. I'll just go to the Koko Eating Banana problem. So let's read the problem description first. So Coco loves to eat bananas. There are n piles of bananas. The ith pile has piles of I bananas. The guard have gone and will come back in 8 hours. So that means Coco, some kind of a monkey is there, and she wants to eat the n piles of bananas with particular hours that we have given. So guards can come back in that particular hour. So that means she needs to finish all these bananas in this particular time. Okay. Next problem says that um, she can eat particular with pace, right? Means for a particular hour she can uh, eat only k amount of bananas only. Each hour, she choose some pile of bananas and eat k bananas from that pile. So that means she can choose which piles to select and how many going to be eaten at that time. So what we have to find, we have to find the minimum pace that she needs to eat so that she can finish in that particular hour, or can finish in less than that hour. Okay. Coco likes to eat slowly, but still wants to finish all bananas before guards returns. Okay. Written minimum integer k such that she can eat all the bananas within hours. So that means our goal is to find minimum number of hours, minimum number of speed that she can eat that amount of bananas. Let's uh okay. We can check into the part of constraints. So we have normal constraints. Okay. So first example says we can have 3, 6, 7, and 11 bananas in the piles, and we got 8 hours. So the answer is 4. Answer says that if she can finish, like she takes 8 hours and she can finish them with pace of 4. Okay, let's understand into the visualization. Make it. So basically, we are checking the speed of bananas we can eat, like Coco can eat. Either it can be from the 1 to the last element, last of these banana elements. So we can have maximum of the piles, or we can have the speed of 1. We can't have a speed of 0 because we can't eat it, right? So we are just checking with 1 speed, can we finish into hours, in second, or in 10 or 8. And this is like kind of a search thing. So this will be a binary search problem. That's how this pattern we can understand. So we can check whether the left side is a proper speed or not. If not, we'll just make left plus 1, or we can do the right minus 1. So that's how the binary search related thing problem is there. Okay. So let's understand it a bit more. Make it. So let's understand the first example that we had. In the piles, we had 3 bananas, 6 bananas, 7 bananas, and 11 bananas, right? So Coco can eat this amount of bananas, can go to this pile, or can go to this pile, or can go to this piles, right? So we have to find a pace. That consider pace is called k. We have to find such a that she can complete in the particular hours that we have given. So for first example, we have given 8 hours. So we have to complete in 8 hours, right? So let's understand here. We can never be eating with the 0 speed, right? Because it will be never going to finish. If we start eating with the speed of 1, then what will happen? Okay. For speed 1, So this many bananas to complete, it will take 3 hours. For this many bananas to complete, it will take 6 hours. Then it will take 7 hours. Then it will take 11 hours, right? So total will take more than 8 hours, right? What we can do? We know this is not a answer, right? So we can check whether we can check for 11 also. For 11, what will happen? We'll finish this in 1 hour, then we'll finish in 1 hour, then we'll finish in 1 hour, 1 hour, and what will happen? We'll just finish in 4 hours, which is less than 8, right? This is also not good. So here we will think about a binary search. We'll take middle of them and check whether 6 is good or not. Like it will complete in 1 hour, 1 hour, 2 hours, and 2 hours. So it will be 4 plus 2, 6. 6 is again smaller than 8 hours because we have to finish in 8 hours, right? Then we'll shift our pointer to the 5 because it's again having slow, it again to the less speed. So this is just consider this is as speed, right? Okay. So we can check for 4. What will happen for 4? We'll just cover first into the first. Then for 6, it will take 2 times. Then for 7, it takes 2 times. For 11, it takes 3 times. Total, it is 8 hours. So yeah, this is our answer. Okay, save this. Go to our coding part. Okay, let's move to coding. As we need to do the binary search, we have to mention 2 variables. One is left and one is right. What can be left? Left is always 1 and right will be the maximum of files is having, right? Then we can have just one uh, response variable which will be having the maximum value of the files, right? This is nothing but we have to store one variable in order to store the minimum of the k that we will be finding. K is the speed, right? So k is our speed. Understand this. K is speed. Now we will do a while loop that is less than, right? Less than or equal to, yeah, we need less than. Then what we have k. K is nothing but middle of this both. As like same like we do into the binary search, right? And we have response that we'll be calculating, right? So we'll just do one loop. Why we are doing here loop? That we have to find how many hours it will take, right? Here, what we'll do, we'll check how many hours it will take for the given speed. So our speed is right now, what will be the speed here? It will be, I think, 5, right? So key in the files and will take one variable called hours, initialize with 0 because in starting we are going to eat into 0 amount because we don't have speed and we have not calculated till this time. So how we will be setting hours? So it will be kind of a sum of t times that we'll be eating files, how much time it taken by k, right? And same like binary search, we will check is this hours less than or equal to the hour that we have given, then we'll just make this left to k, sorry, not, or right to k minus 1, and response that we need to capture here with minimum of the response, or it can be hours. Else we'll just update the left k plus 1, and at the end we have to return k, not k response. So this is small code, just need to think from the side of binary search, and that's it, I think. I'm trying to run the code. Okay. Okay. Sorry. Yeah, we need to compare with the speed, not with the hours. Okay, we pass all the test cases. Yeah. So thank you all for watching.